So like I said, guys, last class we started off with stats, and we talked about how to represent data with an example of just stem and leaf plot, and we found the norms, which are mean, median, mode. Now with this question, two students, Russ and Emily, collect data from their friends, see how many friends they had on Facebook. After they get their data, they look at their numbers, and what they might come to the conclusion is, well, since we all have about the same numbers here, about 72, our friends must all have about the same amount of friends on Facebook. Our friends are pretty much the same. My question to you is, why is that not true? And I think your answer is hitting right on what I was trying to get to. Russ's data starts with 50 and ends on 85, but compared to Emily's data, which starts on 20 and goes to 170, which one has data that's way more spread out? Emily's does, right? And so we can't say, well, Emily's friends on Facebook are pretty much the same as Russ's friends. That's not true. The norm numbers are the mean, median, mode, but not necessarily the data itself. There is a difference. What this might indicate for Russ is maybe all of Russ's friends are all friends together, and so that's maybe why they all have the same amount of, people on Facebook, because maybe they all have friends with each other. Whereas Emily she's just a really different kind of girl, eclectic. She likes to hang out with people that are a little bit more shy maybe, but she also is okay with hanging out with people that are extremely social, and maybe her friends aren't really connected at all. She just kind of is all over the place with her friends. So that kind of goes to show you that even though the mean, median, and mode, the norm values might match, that doesn't mean your data is the same, okay? So let's go ahead and take a look at another point I'm trying to make here. So simply looking at the middle is not enough information to get an accurate picture of data. We also need to consider how the data is spread out. So I want to give you another example. Suppose a teacher was testing some kids and had the following scores on a test: 50, 55, 55, 60. She averaged it and she got 55. She was very unhappy and started some after-school tutoring. Only some of the kids came, and then she gave a test again, and she got the following scores: 30, 35, 65, and 90. She averaged it, and she got 55 again. So she concluded, wow, my after-school tutoring did absolutely nothing. What a waste of time. And why is she wrong? The mode is 55, but we're just looking at the mean right now. But we could consider using a different middle number. That might be maybe that's something wrong that she did. Maybe she should have used a different middle number. But I think I heard a few of you guys also mentioning this. Did all students kind of just stagnate and stay at 55, or did some people actually improve? Yeah, 2 of them did. In fact, half of them. So that might indicate, well, some of the kids that came, maybe those are the kids that raised their score. The other ones got lower, maybe because they weren't studying at all anymore. So was her after-school tutoring useless? No, not necessarily. But my point here is, once again, looking at the middle is not quite enough to characterize your data. We need to look at how it's spread out also. And that's what we're going to do today. Here we go. So we're going to look at measures of dispersion. That's just fancy words for how your data is spread out. So we were talking about that's going to be our focus for the day, because we've determined that looking at the middle is not quite enough information. We want to see how the data is spread out. So you don't need to write this, but we're going to look at things like the range. That's like what Luther was mentioning. He said, well, notice that Russ's data started with 52 and it only went to 85. You're looking at the highest and lowest numbers there, and you're seeing how far apart they are. That's your range. We're also talking about how to find these things called quartiles. You'll see when we get there. Then we're going to do something that some of you might have seen before, a box and a whisker plot. And then we're going to get into something weird that I don't think anybody in this room has seen before, unless you've had Algebra 2 at least, or stats of some kind, something called variance and standard deviation. So let's go ahead and do this. I'm not going to have you write down this whole slide, but I would like you guys to write down the last 3 bullets. So I'll go ahead and give you a moment to do that. Here we go. So how can we figure out how data is spread apart? Well, there's 3 things that we're going to do. First of all, range is one way you can tell how the data is spread out. If you look at the highest to lowest number, that's definitely one way. That's a little bit oversimplifying, though. you could still have the same high and low number, but in the data itself, all the numbers might be clumped towards the extremes, or they could be all evenly spaced. So that's just looking at the high and low is not always enough. So there's also quartiles. That's another way, and we'll talk about what that is when we get there. It's basically like another median. You know how we find the median, the middle number? Well, you do the same thing, but you look at the lower half, you find the middle of the lower half, and you find the middle of the upper half. Now there's an important little note here. If there's an odd number of terms, we're not going to include the median when we look at the upper and lower half. So right now you might be thinking, what is he saying? Well, you'll see when we get there. Let's go ahead and take a look at the last one here. Box and whisker plot. That's basically just a graph. This is a really cool way to actually see how your data is spread out. You have two parts on this graph. You have a box and you've got a whisker, and they tell you where the data is at and how much of it's there. So let's go ahead and do some examples here. Go ahead and copy down this slide. This is supposed to say quarter 3. The median is actually the second quarter, so you can put Q2 above the median if you want. Real quick. Let's go ahead and have you guys write down the first line here in A through D. And then number 1, the data under number 1. So we're going to do a bunch of stuff with this data. Before you begin, you're going to need to put your data in order from highest to lowest. So that's going to be the first task. So let me go ahead and take care of that, and you guys can do it too. I think the smallest one is 42, followed by 55, then 56. And then we have 84, 85. And then we have 91 and 93. Okay? So what we're going to do now is we're going to find the range. So we're going to do the high number minus the low number, right? So let's see what we get from that. The highest number is 93, and the lowest number is 42. And when we subtract them, we get our range, which is 51. All right. Let's go ahead and find the median. We know how to do that. You work your way to the middle. I've got a number right dead smack in the middle. It's 84. Okay, now we're going to find the quartiles. Now let's backtrack a little bit here. Quartiles, it's the middle of the upper and lower halves of the data. But if there's an odd number of terms, we don't include the median. In other words, if you do have a number right in the middle, don't include it in the upper and lower half. So do I have a number right in the middle? Yeah. So I'm not going to pay attention to this when I'm looking at the upper and lower half. So here's my lower half, and here's my upper half. So the lower half will tell me what my first quarter is. What is it? 42. The middle number is 55. So quarter 1 equals 55. And now we'll do quarter 3, which is 91. The middle of the upper half is 91. Now we're ready for our box and our whisker plot. So from the graph that we got in the last slide, you guys see we're going to need 5 specific numbers. We're going to need the minimum number, the first quarter, the median, the third quarter, and the maximum number. So I'm going to switch over here to another slide. My numbers go from what? The low number is 42? 42 to 93. To 93. So I'm going to just go by tens. I'm going to start with 40, 50, 60, 70, 80, 90, 100. All right. So what's the minimum number? 42. My minimum number is 42. What is the first quarter? It was 55, right? What was the median? And the quarter 3 was 91. And the maximum number? So now I just need to plot all these. So I'm going to put a dot over 42 for my minimum, a dot over 55 for my first quarter, a dot over 84 for my median, so on and so forth. Okay, so we're just going to make this into a box and whisker plot now. The two extremes, this extreme and this extreme, you connect them with the whisker. The 3 dots in the middle, you connect them with a box. So what is the point of this? Well, I think it would do really good if we had another graph up here that went from the same numbers, like from 40 to 100, and then you looked at it. Well, what if this one looked like this, though? Well, let's just say we did another one that looked like this. What does that mean? Well, let's talk about it. How much of your data is in between, what percent of your data is what I should say, is in between your minimum number and your first quarter? 25%, right? What percent of your data is between your first quarter and your median? Between the first quarter and your median is another quarter. How about between the median and the next quarter? Okay, now, well, wait a minute, Mr. Bailey. This line's a lot longer than this one. How can they both be 25? Because this just represents the distance between your smallest number and your next quarter, but there's the same number of data in this interval as there are between these two. In other words, on the upper end here, I've got a lot of numbers I've got a lot of numbers that are in the upper range close together, but my numbers in the lower range are really spread out. Okay, is what that means. But they both have the same number of data there. Now over here, the box represents 50% of my data. Once again, the lower half of the data seems to be really spread out, but the upper half is really close together. So what that tells me is that, well, it seems like, I don't know, if we said those were test scores, people that failed kind of failed all over the place, but people that did really good all kind of were around the same area. And that tells you something interesting. So we're seeing how the data is spread out. Let me finish recording here. Now what would this tell you? Well, this would tell you that, once again, it's 25, 25, 25, 25. If we compared these two things, what this tells you is half your data is super close chunked together. Meaning like almost, at least half of the scores were almost identical. They're very close together. Whereas here, the upper half, you maybe had like a few like people really far out here is really spread out. So that's what that information tells you. So this one would tell you here the data is a little bit more spread out than this one. This one shows you the data is really squished together. So, especially the data close to the middle. All right. Now for number 2, I'm going to go ahead and change the data